And now a presentation titled How to Find More Than 150 Vulnerabilities in WordPress Plugins Installed on 15 Million Websites, but by Krzysztof Zając of DeepSense AI. Big applause, please.
Hello. I would like to tell you how to find a lot of vulnerabilities in WordPress plugins. My name is Krzysztof Zając. I'm a software engineer working with machine learning systems. I'm a member of the P4's Capture the Flag team, and sometimes I teach web security at the University of Warsaw. What I'm describing here is a side project. It's a hobby project not related to what I'm doing at work. All right, what is WordPress? This is the most popular open source content management system, which is installed on more than 40% of websites, and you may extend it with almost 60,000 plugins. And the plugins provide various types of features. They provide statistics, they provide image galleries, they may convert your WordPress site into an e-commerce site, an online store, provide various types of functionalities. And in order to build a WordPress plugin, you need to use various types of interfaces to integrate with WordPress, to provide features for your users. For example, you may expose an API. You may tell WordPress that this particular function is registered as an API endpoint, and if somebody calls this API endpoint, something happens. Some input is obtained, some action is executed, and some output is returned to whoever called this API. You may register a menu page, which will appear in the admin panel for all users that have permissions to see that particular menu page. And as with the API case, if the user clicks, some action will happen. Some HTML will get emitted, some logic will happen, etc. Furthermore, you have files, because if you are using WordPress, you are using PHP, and if your plugins and the WordPress core consist of multiple files, and each of them can be, of course, included in the process of normal system operation, but also can be accessed directly, which sometimes is sometimes is a decision of plugin authors. For example, they create a file because they want some functionality to be available from the outside, and sometimes it's not an intended decision because they leave a file to support some functionality and they don't know that it can be accessed directly, and if you access the file directly, something happens that was not intended by the plugin authors. Sorry. All right. There are other types of pieces of code that you may hook into WordPress to be executed, for example, on every page load or in other such cases. What do these all interfaces have in common? So you have API endpoints, you have many pages, you have files, you have other types of hooks. And what do they have in common? They are basically blocks of code that can be executed in some context, in some cases, and they have consistent trust boundary. For example, if you have an API endpoint, you know that it's publicly accessible, or you know the permissions that are needed. And you know that you can provide input, and some code will get executed. If you just have a file lying around, you know what the trust boundary is. If you provide a get parameter to the file, and a file gets removed, for example, then you know it's a vulnerability because you know what is the boundary between trusted stuff and untrusted stuff. All right, so what we can do? We may provide fake input to all these pieces of code. We may provide fake get parameters, fake post parameters, fake headers. How to do that easily? We may create a mock which will pretend to be an array with input parameters, and whatever the parameter name is, it could pretend that, yes, of course, we have this parameter. So this is a fake array, which when asked for example, the secret parameter, returns a payload. So yeah, so we may replace all these in places from where the input is obtained by WordPress plugins by mocks. So yeah, we tell the plugin, yeah, I see you requested the secret get parameter, and awesome, we of course have this parameter. We have all the parameters, whatever you want. And it doesn't work. First, you shouldn't, during the project, I observed that you cannot replace all parameters with a payload, because first, there are parameters that trigger some code paths that are boring because they are not related to the plugin we are testing. For example, if you provide an HTTP authorization header, then some code path related to HTTP authorization is triggered, and the control doesn't even reach our plugin. So I had to manually exclude some parameters. We shouldn't provide a parameter every time it's requested, because sometimes the plugin works like that. If a parameter is set, do this, and if it's not, do that. So therefore, we should randomize the presence of all these parameters in order to cover more code paths. Because they are the two different ways of exposing an API in WordPress, we have to mock both types of providing input parameters. So we're just implementing the same, but one more time. And we need to support arrays, because sometimes the plugin authors take a parameter, treat it as array, and extract a key. So for example, in case of this, of treating the data post parameter as an array and extracting the name key, I solved it like that sometimes I returned, instead of a payload, I returned an identical magic array that pretends to have all the keys, because why not? All right. The last complication I would like to describe in this project was related to providing input, is that WordPress has a behavior to add backslashes before quotes, apostrophes, some characters on all the parameters. I don't know the reason of whether it's a legacy way of providing some form of security. I don't know what is the reason, but it is there. Slashes are added before quotes, for example, on all parameters. We needed to emulate that behavior because it protects the sloppily written plugins from some types of vulnerabilities. And if we did not emulate these behaviors, we would find false positives. We would find something that, some crashes, for example, which look like something interesting, but in actual WordPress installations, when actual website owners actually install the plugin, they wouldn't be there. So we needed to emulate this // behavior. All right. So what we have now? We have some pieces of code which implement plugin functionality. For example, API endpoints. We have many pages. We have files. We may run each of them multiple times, providing fake inputs, randomizing which payloads get returned, randomizing whether a payload gets returned, etc. So we may run multiple times and look at the output. What do we look for in the output? Maybe some of you already have some ideas what could be interesting in such research. For example, if we have a plugin, we executed an API endpoint, or for example, a menu page, we may look for known payloads echoed back. So that's a screenshot from the tool output a word garlic has been echoed back in the HTML output. Why garlic? What has garlic to do with all of that? I implemented the tool in such a way that the payloads contained a known code word, in this case garlic, it is always garlic, to know whether a payload is echoed back, to know whether it is a payload we control. So in this case, we know that we provided some, for example, get parameter, and so observe the same in the HTML output. So yeah, this is a vulnerability, because if we can provide some stuff in get parameters and cause JavaScript to be executed in this web page, then we can send such link to the administrator. And in that case, we can execute arbitrary JavaScript in the context of a logged-in administrator. So we can click a link, send a link, administrator clicks, and some JavaScript gets executed. And what do administrators have? They have administrative permissions. So this JavaScript, instead of showing an alert, could add a user account from the admin panel, because it's possible. All right. Because the WordPress plugins build the HTML output like that, it's just raw PHP. There is no templating language. It's very easy to get the escaping wrong. For example, who of you thinks that the first way of escaping is valid? Hands up. It's written. It's insufficiently as escaped. So sorry. Neither of these two ways of escaping is valid, because of course in both escaping functions HTML tags get stripped, so you cannot just close the link, but you may close the quote and add some events. For example, tell that the link has to be rotating, and on animation start, some JavaScript needs to happen. So yeah, so we look for known payloads echoed back, but it's insufficiently when, for example, we can provide quotes. So yeah, so this is the first thing we look for. Second thing we look for is information leaks. For example, if we execute an API endpoint and we see administrator email or a list of all user emails, yeah, I've seen plugins doing that, then it's an interesting bug, because we know we can extract all the emails from the website. We may look for paths, list of installed plugins, whatever you want. And because the tool is public, if you have an idea of some type of information leak, some type of crashes to look for, and you don't see it mentioned, then feel free to just git clone the tool and implement the crash I forgot, and just run the tool on all WordPress plugins, because why not? So you will find some other bugs. So yeah, so we look for information leaks. We look for, of course, SQL crashes related to SQL injection bugs. We look for attempts to open a file with familiar file name. So if we see that the plugin attempts to open a file containing the word garlic, then it's interesting, because maybe the plugin does something with the file. It shows it to the user, sends it via email or whatever. So maybe it's a way to read files from the server, etc. The next thing we look for is calls to interesting functions. Because if we have a publicly available API endpoint which removes posts, then it's interesting, because it's a vulnerability. The same for post insertion, if we can create posts on the website. Same for example, sending emails. There are plugins which provide an API endpoint to just send an arbitrary email to arbitrary email address. Or, for example, an interesting thing to detect is updating options. It is interesting because some options are powerful. If you can set arbitrary option in WordPress, then you have basically remote code execution. Because first, you may configure WordPress that everybody can register. If everybody can register, you may configure WordPress that everybody who registers becomes an administrator. And yeah, and administrators can install plugins, which is basically remote code execution, etc. All right, and after scanning, after running all these API endpoints, all these many pages multiple times, we crawl the site for known payloads. If we see the word, after scanning, if we see the word garlic added to the menu, then we maybe have an XSS in the menu. So yeah, so this is the way to, this is an additional check which allowed to find multiple stored XSS vulnerabilities in the in WordPress plugins. There were plugins which, for example, exposed API endpoints that allowed to inject arbitrary JavaScript to all posts, because why not? Or configure the menus that you were, for example, able to inject arbitrary HTML to all pages on the site, because it was a menu, so you had control on whatever goes into the menu. All right. During this project, I had to do some, I had to patch PHP a little bit. Because there were plugins which, for example, did checks like on the slide. If the action parameter is set to please remove this particular post, then a post gets deleted. And how did I find these vulnerabilities? It was not practical just to provide all possible strings found in the plugin source into the payloads list, because the list of payloads would be very long, and it would be just not practical. So what I did, if I just patched equality, if PHP detected that equality comparison is performed on a known payload on one side, and anything, whatever you want on second side, with some probability I returned true. The logic behind that was that it could have been equal if you provided correct value on the left-hand side. Of course, it led to numerous false positives. For example, in the form of if the sort parameter is ascending or descending, then inject it into SQL query. So of course, there is no SQL injection there. But yeah, so that technique mostly worked, except cases where it didn't. The second place where I needed to patch PHP was to patch JSON decoding, because the logic was the same as with equality comparison. If I observed that JSON decoding is performed on a known payload, that it could have been correct JSON with arbitrary keys, right? So I pretended that it was a correct JSON and returned fake array which pretended to contain all the keys. So yeah, so it was a way to detect situation where the plugin took some string, decoded it as JSON, and extracted some keys, and for example, did some dangerous stuff on using these keys. Same for so yeah, so I was able to detect a situation like this. The settings parameter is decoded as JSON. I need to strip slashes because WordPress adds slashes before quotes. So yeah, so I have to strip slashes, I decode this as JSON, and I delete post with the ID being extracted from this JSON. So to detect this type of vulnerabilities, I need to patch JSON decode. And the same was needed with base64. The same logic, the same idea. That if base64 is executed on a known payload, that most probably the known payload could have been something base64 decoded. So yeah, so I returned just the same payload. Another place where I needed to patch PHP was adding headers, because sometimes a header is interesting from a security perspective. For example, if we are able to trigger adding a location header with arbitrary content, then we have an open redirect vulnerability. So yeah, so to detect, currently I detect only redirects, but still the tool is configurable. So if you have an idea for other headers that are interesting to be detected, then feel free to send a pull request. What was important in terms of the development of the tool is how to incorporate knowledge about existing vulnerabilities into the code. Because, for example, when I'm browsing the list of known plugin vulnerabilities and I see something interesting, for example, a plugin treats a get parameters as an array, extracts some key, then decodes it as JSON and updates an option. This is from what we already know. This is a security vulnerability. And a good way to incorporate knowledge about such bugs into the further code was to write a test first. So basically test-driven development. I took the vulnerability and wrote a test. If we started the tool on this particular plugin in this particular version, then it should find the crash. And this test ensured that every everything on this list that have to go right in order for this bug to be found are actually supported, and are supported correctly. That arrays are supported, that JSON decoding is supported, that update option is supported, etc., etc. That everything on this chain of stuff that has to be implemented correctly, indeed is. So it was very helpful in terms of the development of the tool. Let me show a demo. I have a video in case the demo doesn't work, but let me first attempt to show a demo. So yeah. Let's assume we are testing a random plugin in an old version, which I know contains an arbitrary file read vulnerability. So yeah, so first we download information about this plugin to create a clean environment using Docker that has WordPress, the database, etc. After waiting for a database server to be present, I load a dump, which contains correctly configured WordPress instance with users, whatever I wanted. Then the plugin gets installed. In case some dependencies are needed, dependencies are installed. And after the plugin is active, I visit the admin panel sometimes in case some hooks are added on first admin visit after plugin install. Yes, I had to do that. And after patching the code, after instrumenting, so to return information what happens, we run code. So maybe not of you see the bottom of the screen, but what happens, I will move it to the top. We have a mini page, and we run it multiple times, providing get parameters. And on other types of parameters. And every dot is one execution. So we execute it multiple times, randomizing stuff. And this is an API endpoint. We run an API endpoint multiple times. So yeah, I will not wait for the tool to finish because it takes more than 20 minutes. But I have a WordPress instance with the plugin install. I will print the findings. All right, so after printing the findings from the tool, we see that it detected, these are findings from a previous tool run, because we didn't wait for this one to finish. So we see that for this plugin, we have an API endpoint, WordPress Ajax RVM import regions, which opens a file with a, well, we already know this file name. So yeah, of course it fails to open this file, because why should it succeed? But we detect this, that after providing all these variables, RVM upload regions file path, then fopen happens. So yeah, so let's browse to an environment I already prepared and find the source code of this API endpoint. We see that there is a file implementing something, so vim rvm ajax imp. Oh, this one. So yeah, we see that the plugin checks whether some variables are present. You may probably appreciate the way security nonce is checked in this API endpoint. This is the only mention of the word nonce in the code of this endpoint. So yeah, so we check whether some stuff is present. We take file path, and we see that the plugin does fopen on this path, and what it does with this data. It treats it as a CSV file, iterates over this, and builds some HTML. So yeah, maybe it's good. Let's see. So yeah, so we see some HTML is built. So we may browse. So we may see I implemented a payload, a request which provides all these parameters: correct API correct API endpoint name, correct security nonce 5, all these variables, but the file name is, you recognize this file path. And after doing this, I see some, after doing this request, I see some HTML forms. So maybe I we don't have a vulnerability. But we do. If we observe the source code, we see what is the source of these HTML forms. Maybe all of you will recognize this thing, or the second line of etc passwd is here. So yeah, so we indeed have the possibility to read arbitrary files from the server and obtain their content. So yeah, so the tool works. And actually, this is a real vulnerability which has been reported some time ago and got a CV, and it's already fixed. All right. So the tool will also show you if the known payload is echoed back. So I already shown that, but it will also show you if some interesting function got triggered. For example, in that case, we update some option which contains some templates, contains some templates, some values that look like they could go in somewhere in the HTML code. So after manually inspecting the plugin source code, we may see that indeed these values are rendered in such a way that allows us to trigger a stored XSS vulnerability. So we may, I don't know where, I don't remember in which of these options stored XSS was present, but in some of these, whether copy template or copy excerpt, if you provide script alert 1, you just got an alert on a page or multiple pages. All right. What are the drawbacks of this tool? First, false positives, which I already described. Or, for example, let's assume if a plugin echoes such JSON, which contains some keys and some HTML output with some payload that we recognize, that we see that we potentially have an XSS here. So, who of you thinks it is an reflected XSS? Who of you thinks it's not? Who of you thinks it depends? Yeah, correct answer. It depends. It depends on the content type. If the content type is set properly, application JSON, then it's not an XSS. If the content type is set to text/HTML, then which unfortunately is it's in many cases is the default, then there is an XSS because the browser will interpret such JSON as correct HTML and run the JavaScript. The last drawback I wanted to describe is time, because in order to test all the plugins, I actually didn't test all the WordPress plugins. I tested only the most popular, starting from 10,000 active installations. And there is 2,500 of these plugins. And testing them took more than 2 months. Of course, after 2 days, you already have some reports to read. So it's not waiting 2 months for the first report. But still, it took time. All right. Let me show you some findings I found particularly interesting. First, let's assume we built a plugin to hide the login URL, to protect you from bots which know the WordPress login URL because it's always the same, and try different logins and login password pairs. So to protect from this, there are plugins which change the login URL to something secret, that you have to know the login URL in order to log in. Instead of wp-login.php, you have something different. So I won't tell you how to build such plugin. I will tell you how not to build such plugin. You definitely shouldn't expose a PHP file which disables the plugin functionality and has well-defined location URL. So yeah, don't do that. Another interesting finding I wanted to show is this. Read this documentation. So yeah, so for those of you which are sitting in the back and don't see, the isAdmin function in WordPress determines whether the current request is for an administrative interface page. It doesn't check whether the user is an administrator. So yeah, so it was a source of a couple of bugs in the form of, if isAdmin, do something dangerous. Another finding I wanted to show you is how not to fix a cross-site scripting vulnerability. One of the top plugins having multiple millions of active installations did something like that. If the ID parameter, it was a fix for an XSS I reported, just for the context. I reported an XSS in the ID parameter. So what they did, they checked the ID parameter, whether it's correct, it contains correct letters or numbers or whatever, and if it was not correct, the die function in PHP just prints in HTML output this thing. So they printed invalid request, and serialize on a string just returns a string with some prefix, some garbage in the beginning and the end. So yeah, so that was an XSS protection attempt. Actually, they didn't need outside help to figure out that it's not a good idea, but yeah. They fixed if they found it themselves and deployed a new version of the plugin. All right. And of course, I got an alert one when preparing the previous slide. The last interesting finding I wanted to show you is this. If the CAPTCHA is set, then verify the CAPTCHA. And if it's not, a friend of mine which is sitting in this room, seeing this code, said that, what's the problem with that? If there is no CAPTCHA, there is nothing to verify, so what's your problem? And I've observed this pattern multiple times, both with CAPTCHAs and also with security nonces. If there is a nonce, then do proper security verification of a nonce that is intended to protect you from cross-site request forgery vulnerabilities. And if there is no nonce, then there is nothing to verify. All right, another finding, another thing I want to share with you is the plugin vendor reaction. There were multiple times where the plugin received a report and just ignored it, or deployed a fix where the initial proof of concept I shared with them also worked, still worked. So yeah, so there were some vendor reactions that didn't meet my expectations. Fortunately, the WP scan, which assigns CVE numbers for WordPress plugins, which is one of the few companies which assigns CVE numbers for WordPress plugins. They have the possibility to escalate a report to WordPress plugin team, and the plugin gets deactivated for downloads in case the vendor doesn't fix the vulnerability in reasonable time or something like that. So yeah, so they helped a lot to motivate the plugin authors to actually fix the vulnerabilities. And this particular RCE, which is unauthenticated remote code execution on 10,000 of websites, was lying around almost a year between first report and the fix. All right, statistics. I found more than 150 vulnerabilities. Not all of them were found directly by the tool. Some were the result of trying to build a proof of concept and finding a vulnerability 10 lines below the original one. And the plugins where I found the vulnerabilities were installed on about 15 million of websites. And what was the distribution of vulnerabilities? Most popular were cross-site scripting, both reflected and stored cross-site scripting vulnerabilities, SQL injections, of course, various types of broken access controls, unauthenticated endpoint to send arbitrary email, authenticated endpoint but available to all logged-in users, for example, blog subscribers, which allows you to remove arbitrary post or create a post or whatever you want. So yeah, so broken access controls and cross-site request forgeries. All right, Of course, I would not show numbers and don't think that has some relation to the distribution of actual vulnerabilities in actual WordPress plugins, because there are two types of biases. First, of course, the tool is biased towards, the tool is able to find some classes, some types of vulnerabilities, and is not able to find other types of vulnerabilities. And another types of biases is the guy who looked at the reports and could sometimes have better skills of detecting looking at the reports and finding one type of vulnerabilities, not a different one. So don't treat this as any statistic. The tool can be extended. For example, you may take the tool and replace the WordPress-specific stuff with Joomla-specific stuff or Drupal-specific stuff and test Joomla plugins. You may add the support of different types of crashes. For example, if you have an idea what I forgot in the crash list, of course, I wouldn't tell you an example of what I forgot for obvious reasons, but if you have an idea, then feel free to git clone and add support for this crash. Another further area of research would be decreasing the number of false positives. It's high, as for now. And experimenting with actual modern fuzzing techniques used in actual fuzzers, not the thing I described earlier. All right, what is the role of the framework? Because in the research I'm presenting, I found some vulnerabilities, contacted the vendors, and they fixed each one. Sometimes they fixed, sometimes they attempted to fix and fixed it after some retesting, but they fixed. It sometimes is not the right way, because the framework may help to build better plugins. For example, if you have an API endpoint, one way of writing API endpoints in WordPress provides you two options. The API endpoint is available to everybody not logged in, and everybody logged in. So the default is either everybody not logged in on the internet, or any logged in user, even blog subscriber or online store customer. So yeah, so these two defaults make you prone to mistakes, because you may be tired, you may forget to add some additional controls and expose an dangerous API, removing posts, to any logged in user. So in my opinion, a good idea would be to providing a secure default. Then you have to explicitly decide that it has to be available to all logged in users. In other cases, it's just admins, I don't know, maybe. Of course, template engine. You don't have template engine. The code doesn't encourage you to use a template engine, and therefore, out of these three ways of escaping, one is correct, and of course, the plugin authors did a lot of mistakes using other one, because sanitize text field function looks very, very powerful. It looks like some security function, so let's do security. So let's sanitize the text field to protect us from XSS. So yeah, so this is another place where instead of finding and fixing every last one of cross-site scripting vulnerabilities, plugin authors may close the whole class of vulnerabilities. Of course, there will still be XSS, but fewer. And of course, food guns. The isAdmin function is a food gun. People will, sometimes if you have a function with correct name, you know that it exists. You don't check whether the, I don't know, square root function doesn't kill your cat. You know that there is a square root function and looks like it's correct. So you don't read documentation for every function you use in your code. So yeah, so this is a food gun, and removing such and deprecating this function will close a whole class of vulnerabilities instead of hunting every last one bad usage of isAdmin in all the plugins. All right, so instead of fixing bugs, the WordPress core team can fix classes of bugs. I couldn't. Thank you. This is the link to the tool. If you want to scan some plugins or contribute, then feel free. Do you have any questions?
Hi, hello, thanks for the presentation. Just a quick question for me to better understand the concept. Why won't you use code scanners to achieve the same objective?
You mean static or dynamic code scanners?
Static ones. If you're still executing, you have Docker files with WordPress plugins, probably you have also access to the source code. So
yes, of course.
It's quite easy to find SQL injection, cross-site scripting, local file inclusions, using some of the predefined rules in static application security tools.
Definitely, so it's another way.
Just a different approach.
Yes, different approach, and
okay.
this one found some vulnerabilities, and static code analysis will find different set of vulnerabilities. So yeah, both are viable.
Yeah, thanks a lot.
Are there any further questions? Here at the front.
Can you repeat how does your tool know when a dangerous function is called with the garlic string? How do you intercept the function calls?
I'm not very proud of this solution. I just injected prints at the beginning of WordPress function. For example, WordPress delayed post, and detected these prints with a huge pile of regular expressions. So it's not something to be proud of, but it works.
It works. Thank you.
Next question.
So not very technical question from my side, but I can imagine that lots of plugin developers are not corporates, maybe small team or single developer.
Yes.
Can you share your experience of reporting these vulnerabilities to them, how they react? Do they often ignore it, or are they thankful to you right away? So have you like a bit, what's your experience with that?
There was a large fraction of plugin developers ignoring or not being thankful, but there was also a large fraction of plugin vendors providing free premium plugin versions instead of bug bounties if they were indeed small startups. So they were both types of reactions. Nobody threatened to sue me. So yeah.
Okay, are there any further questions? No, okay. So if anybody has maybe different questions or something, I'm sure you can find Krzysztof in private later. So now a big applause, please, for Krzysztof Zając.